Okay, so as with the paper one, I've given you a grade breakdown here for the grade boundaries for this June 2017 intermediate tier paper, where you were looking to score 33 out of 80 would get you a C grade, obviously provided you got 33 out of 80 as well in the first paper, which when you look cumulatively down the questions means that you need to get everything right up to and including question 9. If you do that, then you are into the grade B territory. So let's see how these questions look. Okay, so we're going to start off with some percentage and fraction work, and remember this is a calculator allowed paper, so make sure you use your calculator. So often I see when I'm marking GCSE paper 2s, students trying to work that out by first finding 10%, 30% and so on, which if you get it right is fine, but it's wasting time and there's the potential for getting it wrong. So 39% of 576. You could use the percent button on your calculator, which is above the open bracket. So you could write 39 shift percent of means times 576. So you've almost written it exactly as it's written, and you get the answer £224.64. Make sure you get the context. Or if you want to, you could just write that as 39% as a decimal. You should be able to do that straightforwardly enough. 39% is the same as writing 39 pence written in pounds. As we've established, of means times 576, and you're going to end up with the same thing. So just to be sure, 0.39 times 576, 224 pound 64. 3/7 of, again, your scientific calculators now enable you to just type that in exactly as you've written it there. So 3/7 times 100. So that's 42.8, etc., etc., etc. We just write that down. They want the answer to the nearest whole number, so we need to give the answer as 43. How many quarters are there in 100? So this one might catch you out. If that was to say how many threes, sorry, in 10, the question was saying how many threes there were in 10, you'd probably work it out. You'd know you're going to be doing 10 divided by 3. So what we have to do here is 10 divided by a quarter. And you type that in your calculator just as I've written it. 10 divided by 1 quarter, 40. There are 40 quarters. If you think that sounds a bit weird, well, if you think that there are 4 quarters in one hole and you've got 10 holes, so you've got 10 lots of 4 quarters, which is 40. What fraction is equal to 50% of 1/6? Well, let's type that in the calculator as we see it. 50% of 1/6 equals 1/12. So don't be afraid of using your calculator. Circle the fraction that is a recurring decimal. Recurring decimals are shown by a decimal which has a little dot above one of the decimal numbers. So all we need to do here on our calculator is first of all type in 21/35. 0.6, that's not. 10/12 equals and there you can see 0.83, and there's a dot above it, which means that would be 0.8333333 forever. It's the fraction, so there's only one, so we can put a circle around that. As far as the mark scheme is concerned for that question, you got a method mark for however you decided to do that, using the percent button or decimal or writing it over 100, doesn't matter, and 1 mark for the answer. And if you didn't put the pound sign in, you wouldn't be penalised. For the second one, you get 1 mark only if you saw 42.8 blah blah blah. The second mark is for correctly writing it to the nearest whole number. This one, 40, just 1 mark for that answer. 1/12, just 1 mark, and just 1 mark for that. Okay. Circle either true or false. Now, when I mark these sort of questions, I despair that just because it's a true or false, it seems that the candidates are guessing. Just because it's true or false doesn't mean it's not going to help you to do any calculations if it helps you. So these questions are all to do with triangle properties. A triangle with one angle equal to 70 degrees could be an equilateral triangle. Well, you should know that an equilateral triangle has all equal sides and all equal angles, and the angles of an equilateral triangle are all 60 degrees. So that is false. So that's just a key fact. There's no maths to do there. A triangle with one angle equal to 70 could be an isosceles triangle. Well, yes, there's 2 ways that could be true. It could be true with a triangle where that is 70, that is 70, that adds up to 140, which would mean that. Or you could have that being 70, which means those two would have to add up to 110 and be 55 and 55. So either of those make that one true. A triangle with one angle equal to 70 could be a right angled triangle. So that would mean that that is 90, that is 70, those add up to 160, which means that would be 20. So that could be true. An isosceles triangle could have one of its angles equal to 105. Well, it couldn't have it couldn't have 2 angles of 105, but if it had one at 105, let's say that one, then that would leave 75 out of the 180, which you could divide by 2. So 75 divided by 2 is 37.5 and 37.5. So that could be true. A right angle triangle could have one of its angles equal to 105. Well, 90 plus 105 is greater than 180, so that's not true, because they all have to add up to 180. So, marks for that question, 3 for all 5. Um, 2 for 4 correct, or 1 for 3 correct. Question 3. Calculate the answer when the largest prime number that is a factor of 28, so the largest prime number that divides into 28, which is going to be 7, is multiplied by the smallest prime number that is a factor of 15, which is 3. So the smallest prime number that divides exactly into 15 is 3. The largest prime number that divides exactly into 28 is 7. Calculate the answer when those two are multiplied together. So you're looking for an answer of 21. 2 marks for that. 1 if you get the 7 or the 3. Okay, so if we've got all of those right so far, we're on for a Grady. Question 4. The diagram below shows a number machine. Using the number machine, calculate the input when the output is 36. So if we know that that's 36, we have to go backwards through the number line, the number machine. And the rule is, if you travel backwards through a number machine, you do the opposite to the operators. So we're going to do 36, which we're going to divide by 3 to give us 12, and then we're going to subtract 7 to give us 5. The output when the input is n. So we do n, add 7, and then before we multiply by 3, we have to work out what that is. We have to evaluate that. So in order to do that in algebra, it means put a bracket around it and then multiply by 3. So marks for that one. 1 mark for 5, and for this one 1 mark if you'd written that n plus 7 times 3 without brackets, which is wrong, because then the only thing that's multiplied by 3 is the 7. Write down 3 integers, all less than 25, whose range is 8, so the difference between the biggest take away smallest is 8, and the mean is 13. Now, the bit there that most candidates miss out is that if they're telling you the mean and you know there are 3 numbers, you can work out what the total is, because the total will be the mean times 3, because the mean, let's write down here, so the mean is the total divided by the count. The total is how many there are divided by, is what they all come to when they're added together, and the count is how many of them there are. So to get the total in its own, we'd multiply by count. We'd have to multiply that by count. So the total is 39. So these 3 numbers have to add up to 39, and the biggest take away the smallest must equal 8. So if there's 3 numbers, then they're likely to be around 10. So let's try with the smallest being 10. So if the smallest is 10, the largest is 18. 10 add 18 is 28. So in order to make them add up to 39, I'm going to add another 11. So 10, 11 is in the middle. So 10, 11 and 18 will do it. There are other ones as well. I was just got lucky that I chose 10 to start with. So just go through that again. If we know the mean and we know however many numbers there are, we can multiply that together to find the total. So we're looking for three numbers that add up to get 39, and the biggest and the smallest number must differ by 8. So if I pick my smallest number as 10, that means the biggest number is 18. So long as the difference between those and 39 come in between them, then we're in business. So those come to 28, which means I need to add another 11 to get 39. 11 is in between there, so those are my numbers. 2 marks for that. Right, on the first 3 terms of the sequence whose nth term is given by 2n minus 5. So the first term will be when n is 1. So the 2 and the n in algebra, you don't put the times in, but when we replace that with a value, we have to put the times in. So that's going to be 2 times 1 take away 5, which is 2 take away 5, which is negative 3. The second term, we replace the n now with a 2. So it would be 2 times 2, take away 5, which is 4, take away 5, negative 1. And the third term would be 2 times 3, take away 5, which is 6, take away 5, which is positive 1. So the first 3 terms, negative 3, negative 1, 1. Write an expression for the nth term of the following sequence. So this time they're giving us the sequence, we have to come up with the algebra. The first thing is to look what the differences are. They're going up in 4, which means it's a 4n rule. It's basically the 4 times table that's been shifted. And it's been shifted by, well, the first term isn't 1 is 4 is 4. You've got to add 3 to it to get to 7. So the nth term rule is 4n because the difference is 4, and then what do you have to do to 4 to make the first term? And the answer is add 3. Marks for that one. 2 marks for that. 2 marks if you get any 2 correct. 1 mark if you get, sorry, 2 marks for them all right, 1 mark for any 2 correct, 1 mark for the 4n, 1 mark for the plus 3. Question 7. A dice is thrown 50 times. The number shown on the dice is recorded after each throw. The table below shows the results recorded. So whenever you're working with the table, make sure that you can understand what each corresponding pair of numbers is telling you. So if we pick this one, for example, what is this telling us? Well, it's telling us that out of the 50 times the dice was thrown, the number 3 occurred 8 times. This is telling us the number 5 occurred 6 out of the 50 times. The relative frequency of throwing a 1 was calculated as 9 out of 50, 0.18. What was the relative frequency of throwing a 6? Well, the 6 came up 13 out of the 50 times. Give your answer as a decimal. Well, you could do it in your head, but if you're not comfortable at doing that, then if you write it as 13 out of 50 equals, and press your SD button, There you go, 0.26. The number 4 was thrown 7 times in the first 50 throws. Using this fact, calculate how many times you would expect a 4 to be thrown when this dice is thrown 3,000 times. So the relative frequency is going to be 7 out of 50. And then to work out how many times that's likely to occur, we would multiply it by the 3,000. We put that on our calculator exactly as we see it. So 7 out of 50 times 3,420 times. How many times would you expect a 4 to be thrown when a fair dice is thrown 3,000 times? Well, if it's a fair dice, the chances of a 4 coming up is 1 out of 6. So we'd multiply that by 3,000. And get the answer 500 times. So marks for that. 1 mark for the 0.26. A method mark for showing what you're trying to do, and an answer mark, and a method mark for that, and an answer mark. Question 8. ABCDE is a regular pentagon with a center O. Calculate the size of angle X. Well, if it's regular, that means that all the sides are the same length and all the angles are equal to, which means in the center there we know that there are 5 equal angles joining that around that point. Angles around a point equals 360. So 360 divided by 5, 72. So that angle there is 72 degrees. Because it's regular, that side and that side are going to be the same. But it's not that side as well, otherwise it would be isosceles, and that would be equilateral, and that would be 60. So triangle OCD is isosceles. So to work out X, we do 180 take away 72, which is 108. So the 2 bottom angles must add up to 108. So we're going to divide that by 2 to get 54. So they've left you a whopping great pile of space there, but basically that's all you're doing. Some marks for that. There's 2 marks for the 72, 1 mark for showing you division, 1 mark for the 72, and then 1 mark for doing the 180 take away the 72 divided by 2, and 1 mark for the answer of 54 degrees. Alright, so if you made no slip-ups, we got ourselves a grade D. Question 9. Look at the diagram below. The expression in each circle is found by adding the expressions in the rectangles on either side of the circle. Complete the diagram by writing expressions in the blank circles and the blank rectangle. You must simplify your expressions. So what they're saying is to find what's in the circle, we're going to add that rectangle and that rectangle together. So 3x and 1x is 4x, 1y and 4y is 5y. So if we do that for this one, we have 4x and 1x is 5x, and we have 4y, take away 1y, is 3y. For this one, we already know what the sum of them is, so we have to work out what have we got to add to that to make 8x. Well, 3x plus 5x will be 8x. What do we have to add to y to make 3y? 2y. So to fill in that circle now, we have a 5x and a 4x is 9x, 2y, take 1y, plus 1y or y, either of those is right. And there's 3 marks, 1 for each. And if you got one of those wrong, they would follow through for that, as long as you got it correct from your wrong working. Question 10. Okay, so this is the communication question. ABCF is a rectangle. ABCF is a rectangle. CDEF is a trapezium. Now, immediately I'm thinking trapezium, look at your front page. It's telling you there how to find the area of a trapezium. So we got that ready to go. Just pull that out ready in case I need it. BD is a straight line. AB is 7 centimeters, BD is 9 centimeters, and DE is 3. The perimeter of the rectangle ABCF is 24 centimeters. So the distance all the way around that is 24. Calculate the area of the trapezium. So in order to find the area of the trapezium, I need to know A, which in this case is 3. I need to know B, which in this case, because that's a rectangle, that is the same length as that, is 7. And I need to know the H, the height. Well, at the moment, I don't know that height. So I need to find the height. So if the perimeter of the rectangle ABCF is 24, these two sides, sorry, AB and FC, come to 14. So total length of shorter sides will be 24 less 14 less the 7 and the 7. So that's 10 centimeters. So that side plus that side is 10. So one short side would be half of that. So I now know that that is 5. So if that's 5 and that's 9, DC is going to be 9 less 5 equals 4 centimeters. So my trapezium, I know, is 7, 3, and 4. So the area is a half bracket A plus B close bracket H close bracket 4. Okay, we know in algebra where there aren't any symbols, that means there's actually a times there. So that is half times that times that. We know we need to work out the brackets first. So that's going to be a half of 10 times 4. 10 times 4 is 40. Half of 40 is 20. And its area, so we need to give its units correctly, which is going to be centimeters squared. So OCW, I haven't written an essay, I haven't done all the maths and then written a story underneath. I've just carefully written what I'm doing as I'm doing it and annotating my diagram as well. So from a maths point of view, there's 2 marks for getting down to finding that side is 5. So a correct method for getting the length of the short side of the trapezium. And then one method for subbing in to your trapezium rule, and 1 mark for your correct answer of 20, and then an additional 2 for how you organized and laid out your work. And if you get that correct and you've got everything right up to that point, then you are worthy of a grade C.